A special type of normal distribution is the so-called standard normal distribution. We have standard normal distribution when the variable's mean is equal to 0 and the standard deviation is constant and it is equal to 1. So standard normal random variable is a random variable with standard normal distribution, so with the mean being equal to 0 and standard deviation being equal to 1, and this variable will be denoted by the symbol z. So, and this graph is a quick representation of standard normal distribution. So as you can see, the mean value is in the middle, it is equal to 0, and standard deviation is equal to 1, and it is constant throughout the values of z. So because we can see that the intervals are the same, the length of the intervals is the same from 0 to 1, from 1 to 2, from 2 to 3, and from 0 to -1, from -1 to -2, and so on and so forth. So to get the probability for this type of distributions, to get the probability of a standard normal distribution case, we will use a special table, a part of which you can see on this slide. So in this table, what we have is the p-values, and they denote the probability that z, which we can see in the first column, lies in the interval from 0 till some specified value in the first column. So for example, if we're interested in the probability that z lies between 0 and, let's say, 1.11, so we will need to go all the way to 1.1, but since we're interested in 11, we will move to the third column, representing 0.01. So the probability that z lies between 0 and 1.11 is something like 0.3665. So let's have a look at the example. For example, if you're asked to find the probability that the standard normal random variable z lies between -1.33 and 1.33, you will need to do a couple of steps. So we've got an interval consisting of two values, so we actually got two, as we will call them, z-scores. So z1 is 1.33 and z2 is -1.33. And the most important aspect of normal distribution is that it is symmetric around the value of 0. So the values to the right of 0 is the same as the values to the left of 0. That means that the area between 0 and 1.33 will be the same as the area between 0 and -1.33. So using the table, we can find the probability that z lies between 0 and 1.33, or in mathematical terms, we can find the area between 0 underneath the curve between 0 and 1.33. To do that, we will open the table. So we need the z-score of 1.33, so we go all the way down, 1.3, and we need 0.03, so we move to the right to the column representing 0.03, and we get that the probability that the z-score lies between 0 and 1.33 is 0.4082. And once again, since this is a symmetrical situation, this area to the right of 0 will be the same as the area to the left of 0. So A1 plus A2 will be just 0.4082 plus 0.4082, and we get that the probability that the z-score lies between -1.33 and 1.33 is 0.8164.